ऑलराइट, चलो गला भी खराब कोई नहीं, लेकिन लेट्स स्टार्ट ऑफ. Alright, so assalamu alaikum everybody. We are live and let's start off with today's class. So in yesterday's class, we had a pretty good discussion on how do we represent text, right? So we studied what's ASCII, what's character set, what's extended ASCII, what's Unicode. We had a general look about how, if for instance there is a user who might want to type the letter A, then how can they do it through this mechanism? What's the character set? How does a specific character set have the binary for a specific letter? And when you press a specific button, how does that lead to a completion of a circuit? And then afterwards, क्या कहते हैं, once we sort of press the button and the circuit is completed, how does the CPU evaluate that this person is trying to say the word H, or maybe the character E, or the character L? So we had a pretty comprehensive class on that yesterday, discussing all these possible combinations. Today, inshallah, we're going to be diving into the topic sound. So when you hear the word sound, you might be saying, okay, sir, what do you mean by sound? So, like, if I'm currently taking this class, I have a laptop with me that is making use of a microphone, right? So I'm basically using a device known as microphone, which allows me to provide or maybe speak, and then this microphone converts my speech, or maybe I can say the sound which I'm producing right now, because even if I say woohoo, that might be a sound, it's not a text or something. But whatever this is, your microphone is converting the speech and sound into a digital form, into a digital. And when we say the form digital, we basically mean to say what? We try to talk about the form which the computers can understand, which means binary. So your computer, or today, basically the main agenda of today's class is going to be how a computer basically takes a sound from a microphone, which is like an input device, and then basically convert that sound of a speech or sound nature into binary, and then further evaluate that based upon whatever calculations we need to perform. So yeah, so first and foremost thing here to note is that when we say that something is of a form which we humans can understand, so like maybe if I say hello, hey, my name is Mars, or something. Now if I say my name is Mars, or if I say hello, this is something which I can understand. So if I say hello, the word hello is something which maybe I can understand, which Ramin can understand, which Inaya can understand. But your computer does not understand what we mean by the word hello. Why? Your computer can only understand 0 1 0 0 1 0, or whatever the equivalent of this hello is in terms of binary. Now, an important uh, point here to note is that this hello is basically an analog form of data. Okay, so this is basically analog in nature. So if ever in computer science you're approached with the word analog, you should be aware that the word analog basically means that we are talking about a data form which the humans can understand, say. And then when we basically convert it, this form, this is basically known as digital. So any data or anything which is stored digitally, or something which is given the sub name of digital, or maybe I can say digital data, digital image, you should understand that this basically means that we are talking about a method, we are talking about a specific data type which is in binary. So digital data might not be something which we can understand. So like if I say 0 1 0 0 1 1 0, you might not be able to make sense out of it. But if I say hello, my name is Mars, you can make sense of that. So for humans, it's basically analog. So I can say if humans were to understand something, they have to do it through analog. Otherwise, digital is basically for computers, or you can say electronics. But it's something, if you can understand what 0 1 0 0 1 0 might mean, तो आपको आसानी से याद भी हो सकते हैं, not that big of a deal. So, so now in today's class, we're just going to be understanding that how does a computer go from this hello to a 0 1 0 0 1 0. So this process which we are going to be studying today covers up several key definitions, and these definitions which we are going to be inshallah discussing today are something जो कि आपके examiner को बहुत ही अच्छी लगती है, बहुत ही अच्छी लगती है, and they always sort of gives you questions. So inshallah when we will be doing those past paper questions, you will be noting कि हम काफी इस तरह के questions करते हैं. So the main stage in which you basically go from an analog to a digital data type, oh my bad, digital sound data type. This process is basically known as sampling. Okay, So the name of the process is basically sampling. So we need to basically study what sampling means, what is basically sampling all about, इसमें होता क्या है, what's the purpose of sampling, how does it work, and all that stuff. See? So now, before moving on, I want you guys to tell me one thing. When we say sampling or when we say microphone or whatever thing of that sort, or if I say that I have a microphone, or maybe if a specific thing is being recognized by a device, what aspect or maybe what feature of my sound might it be recognizing which can allow it to maybe understand that yeah, this is this specific thing? Like what is that one thing in my sound which can allow the computer to make differentiation? If I say hi, that's a bit high pitch, right? Hi, that's a lower pitch one. What's the difference between these two sort of sounds? Any idea? All right. So basically, this the difference between these sounds or the way we are going to be talking to the computer really depends upon the vibration. So if I say, okay, Ramin is saying amplitude. Okay, Ramin, amplitude is a good word. It's the right one. It's basically talking about how high or low I might be speaking. But in reality, if there is a microphone in front of me, okay, if there's a microphone in front of me, the thing which can allow the microphone to understand what I'm saying or maybe what I'm speaking is basically dependent upon my vibrations, and basically vibrations again depend upon the same amplitudes within of a sound wave. So you're correct, but at this point you need to understand that your computer, whenever you have a microphone, they operate and they look for your vibrations. So your microphone takes in your vibration, or I can also say your sound waves, because sound waves are basically your vibrations in the air. So I can say sound waves. And based on this, what happens is then it sort of figures out कि यार देखो, if I'm taking a specific vibration in, we can see that over time. Perhaps wait, just let me post this one image and फिर उससे आप लोग को अच्छी समझ आ जाएगी what I mean by this whole concept. See, it's not that complicated. It's pretty much very straightforward. See, so this one diagram is in discussed there in your book, and it is basically explaining the process of sampling. So what happens is that when, let's say, I'm trying to speak in front of a microphone, so at one point I might be speaking a bit louder, right? So I might speak a bit louder, and then at the other point I might be speaking a bit lower in voice. So yeah, sometimes I might be speaking very high, of a very higher or maybe fast pitch, whereas at some time it might be very much low. So now coming to the main point, Ramin, which you said about amplitude. Now we're going to be discussing that. Now, if I have to shout or something, or do something of like a higher pitch, whenever I speak into the microphone, I'm like, hi. So if I'm doing something like that, this means that a higher sound will basically be having higher amplitude. So higher amplitude, or maybe write it like this: amplitude with an upper arrow. So it's going to be having a higher amplitude. And if I have to speak something in lower voice or lower thingy, it's going to be having a lower amplitude. See? So when your computer, basically microphone, when the microphone takes in your vibration or maybe the sound waves, or I can also say your sound or voice, it's basically going to create a diagram like this. And this diagram is basically of sorry for that. So this diagram is basically the diagram of the sound waves, because we are well aware that if I have to make a specific wave signal, if I have a specific sound wave, you will also be studying this in your physics class, inshallah. That once you study the chapter regarding, I don't know what it was back then, but whatever about waves, you're going to understand that whenever we have a sound wave, which are basically vibrations in the air, they can be represented through a diagram which will be having an amplitude and maybe some time interval at this point. So the amplitude basically means the maximum distance it can cover. So now look up here on this diagram, you can observe that this basically has multiple sort of different amplitudes. At some point, maybe like right now, I might be speaking a bit louder, but at the next moment, I might be like at minute number 2, I would be like, नहीं यार, फिर ऐसे भी तो नहीं करना. And then the other moment, no, guys, the answer to this is this. So we have basically multiple sort of this. This diagram is basically made upon the vibrations which the computer understands. See? So your vibrations allow your computer to make a diagram like this. Say, so we have your vibrations, and these vibrations basically allow your computer to create such a diagram. Now, what your computer does is they basically interpret all this maximum amplitude and vibrations into binary. So they convert these vibrations into binary. How? They might be like, okay, this person is talking out, maybe is making the sound, maybe I can say, hey, like H ka, let's say I'm saying H. So H might be something which can have an amplitude of 9. So what the computer will be doing is that it's going to make use of a process known as sampling. And in sampling, what's going to happen is the computer will be basically averaging the values over set intervals. So like maybe at interval number 1, it's having the value 9. So the computer will know that if I average this part, it will be having a specific binary value of, let's say, let's assume 1100, and this 1100 can be a sound of like H, the letter H. Okay, then it can be like, okay, the next moment it's basically taking an average from this part. So the average of this part might be, if it goes and it can find like maybe the middle point is something like this might be something like K. Okay, so K is like KEY. Let's say, no, I wrote it as like E, but let's assume this K, this is making the sound of K, and this might have a sound binary code of 0011, right? So what your computer does is that it basically takes the amplitude and then it calculates the average at each point. And then based upon the average value, it's going to assign it a specific binary value. So it might be saying that if there is something of the sound H, the average of that amplitude has to be 9. So like definitely every time I'm saying H, H of the same frequency and of the same amplitude, the graph, you will see that if I'm making a graph and I say that this end point is basically indicating that I'm making the sound H of a specific vibration, then if let's say this is something else and I again make something of the same length, with the same distance, so like it has the same amplitude, this is a clear indicator that this part and this part is basically making the same sound. So they both have the same sound. Okay, so based on this methodology, your computer scientists, what they did was that they basically created a wave, and then based upon that wave, what they did was they calculated the average amplitude over a set interval. And then they were like, okay, 1 second पे कौन से sound है, 2 second पे कौन से, 3 second, and based upon every sound which it heard, it basically set, it provided a specific binary number for that. So like later on, when it was basically looking up and he was observing that, okay, this 9 may be similar to this one, then if this was given the sound key, let's say K, okay, and it was having the binary 0011, so like when it's again interpreting, it can understand, okay, this part will also be making the sound K. So now this was just for your understanding. It's not like that in exam they might tell you कि भाई यहाँ पे क्या हिसाब हो रहा है, or maybe if this is providing the sound this, what will be the sound up here. You won't be getting questions like this, but usually this diagram is something which a lot of students are confused about. They do not understand the purpose behind what's happening up here. So for your knowledge, you should be aware that this diagram is basically going to be discussing concepts related to how you are basically averaging every sound. So we take the average of each sound. Let me write it up here for you guys too, so that you can write it out later on. So a sampling uh, includes taking average of a specific sound amplitude at a set interval, at a set interval, and then this average value, average value is given a binary value, and then this binary value is basically stored in your computer. So like later on when you want to replay the audio, or maybe want to ensure that the audio comes out of the speakers, so it's basically going to work in a way. It would be like, okay, we have the binary 0011000011. So the computer is going to go and it will be like, okay, bro, wait, let me check in the memory. This was basically making a sound of amplitude 9, this was making an amplitude, let's say, 2. So let's make a sound based on what we have in the memory. 9 wala was something like H, and then 2 wala was something like K. So HK. So if I say HK, or maybe Hong Kong wala HK, so this binary might produce the sound HK. So this is basically how your computer converts your speech into digital form. This process, which basically where the sampling takes place, is basically a component which we will be later on studying in chapter number 3 too, inshallah. The component that allows sampling, the component that allows sampling, or I can say where the sampling basically takes place, is known as is known as it has a very very easy name, and that is basically analog to digital converter. So we studied in the start of today's class that anything which the humans can understand, it's basically in the form data, analog, right? And then we convert it into a format which your computer can understand, which is basically digital. So the converter which allows this process not only necessary for your um, sound purposes, like if for whatever, even if it's a sensor or whatever, if it's basically converting any analog data into a digital format, it is making use of ADC, which is an analog to digital converter. Now at your point, you just need to be aware that this component is being used, but we would be discussing this later on more depth in chapter 3, inshallah. So we would be discussing this later on, inshallah, in chapter number 3 too, once we are discussing sensors and all that stuff. So this basically is a general overview of how your computer basically converts a microphone speech into a format which the computer can understand. Now, before moving on, I want you guys to quickly let me know in the chat box, is this 100% clear, or do you guys have any sort of questions? If you have any questions, just send them in the chat box. Perfect, Anaya. Perfect. Ramin, do you have any questions, or are you good to go too? Perfect. That's great. Acha. So now we have studied sampling generally. I mean, generally, pata lag gaya what's sampling and all that stuff. Now, there are a few keywords which if you remember, I even stated earlier on that you guys should be aware of what does those specific keyword mean. So yeah. So the first keyword which you guys should be aware of is the word sample rate. Sample rate. So if in exam they tell you, bro, define sample rate, or match the column, or maybe fill in the blank, what's the sample column? So you should be aware of the exact definition, and it's pretty easy. It's basically the number of samples taken per second. Number of samples taken per second. Now, you might be wondering, sir, what does this mean? This basically means that if I'm having a graph like this, okay, and then that graph is something like this, okay, something of this nature, and I say that this might be 1 second, okay, this might be, or maybe this might be 1 second. This means that I'm basically taking one interval at this point. So I would be basically averaging what part? I would be basically taking the average over this part, right? So I would be seeing, okay, this might have the maximum of 7, 0, and maybe the average amplitude of this sound is like 3.5, right? How did I get that 7 plus 0 by 2? Like, this is generally, say it just for your own knowledge, we're just calculating the average sound, right? So average amplitude aapka aa gaya around 3.5, which means that, okay, this whole section, which is like maybe 1/8 of the whole audio file, is basically having the amplitude 3.5. Now I took one sample up here in 1 second, so I just took one sample, right? I just took one point. But what if I extend this a bit and I'm like, okay, bro, in 1 second, rather than taking one sample, let me take, like, if this is 1 second, I would take three samples. So I can take one sample up here, like this, then I can take one sample up here, and then one sample up here. So this might be like something indicating or 2. This could be indicating something like 5. This could be indicating something like 6. And now you tell me, if I take an average up here, and up here, I can have, within 1 second, I can have three distinct voices, right? So over a period of just distinct voices. So over just a period of 1 second, now I have three possible sounds. So like up here, this one sample might be indicating the word H. But now you tell me, if we are in a studio and I have the guitars being played up, and I have, let's say, some drums being used, or maybe I have a vocal sound too. So अगर वो सारे एक ही सेकंड में एक इंटरवल हो रहा है, so maybe it could only be including the sound of the guitar. So you might not be understanding, oh, where is the drum sound going? But when we are taking multiple sort of samples over 1 second, or I can say when I'm increasing the sampling rate, which is basically what it is, the number of samples you take per second, then the benefit is that at one point, maybe let's say I have a voice where the guitar's volume is going to be high at maybe times 0.3, and then let's say the next second the violin voice is basically very high, 0.5 second pay, and then maybe at the zero point 0.9 second I can see that the drums voice is very high, and now when I mix them, it's going to give me a high quality audio, high quality audio. So this basically, whenever you're asked in exams that what's the impact of having a higher sampling rate, तो आपको पता होना चाहिए, because a higher sampling rate or a sample rate, because it allows you to have multiple samples taken every second, which means that the average value which we might be getting across the curve, it's not something like जैसे इस scenario में देखो, the average of 0 to 7 is basically 3.5, so we might be only getting the sound of this point, but now up here we can see that our audio is coming from this point, also at this point, and also at this point. So because we have multiple sort of audios up here, the quality is of the video is also going to be very high because of the three distinct voices we might get. So one important point here to note is that when we have a higher sample rate, high sample rate allows a better audio quality. Better audio quality. This is something which you all should be aware, because they usually give a question on the impact of basically making or maybe increasing the sample rate. So iska aapko idea hona chahiye. Then apart from that, we also have, let's say, one other concept, one other important keyword which you all should be aware, and that is basically known as sampling resolution. Now your sampling resolution is also something very much similar to sample rate, but it's a bit different, because this is basically talking about storing the specific file. Say, so remember we yesterday, or maybe in whatever class, we were discussing the concept of registers. Oh, balki kal ki class thi, when we, let's say, have a larger ASCII, let's say we have a Unicode. The benefit of Unicode is that it can have multiple characters, right? But the drawback is that it basically uses more number of bits. So the same concept also gets applied to your sound part, where we are first going to be saying what sampling resolution is. So sampling resolution is basically the number of bits required per sample. Say the number of bits required per sample. I'm coming to its explanation. Don't worry. Required to the number of bits required for what? Wait a second. The number of bits required per sample. Okay, yes, per sample. So the number of bits required per sample. And another important point is that you should be aware that in your book it is also referred to as the bit rate. Okay. So if in exam they ever ask you define bitrate for a sound, या बल्कि bitrate नहीं, sorry, bitrate तो आपके उसमें होगा. It's going to be bit depth. Yeah, bit depth. Bitrate आगे होगा. This is going to be bit depth. So if in exam they give you a question that what's bit depth, तो आपको पता होना चाहिए. It's basically the number of bits required per sample. And I guess I messed up the spelling for this too. It's referred, maybe. Yeah, I guess. What's the spelling of referred? Is either REFF तो होने नहीं चाहिए. Let me check. Okay, it's double R. My bad. It's double R. Okay, so we have R up here too. Never mind. So now when we're gonna basically talk about sampling resolution, the concept here is that let's say I can have a 500 rupees mic. Okay, so I have a microphone up here. This is a microphone. Okay. This is the microphone which you might be using for your school assembly. Oh yeah, admit kyun gaya. So we have a microphone up here, and then we have a big microphone, those gaming microphones, something of very high quality, and it's being connected to a stand and stuff like that. So we have this higher quality microphone of range, let's say 30,000, and this one is really of microphone of 500 rupees. Now, what's the difference between a 500 rupees microphone and a 30,000 rupees microphone? Definitely, we are well aware that this one is going to be having a lower quality. Whereas a definite सी बात है that this expensive one would be having a higher quality. And now we do understand that this one might be having a higher quality because it has a higher sample rate. At the same time, it also has a higher sampling resolution, which means that if I have multiple sounds, like मुझे एक बात बताओ, if I create a 4-bit register, 1, 2, 4, 8, it can maximum possibly store how many values? It can maximum have 15 values. in terms of dinner, right? 1, 2, 4, 8. So if I turn all of them on, it can maximum have 15 values, which means that if I have limited number of bits per, like we say, that then if we have limited number of bits per sample, the number of possible sounds it can store, that is also pretty limited. So like maybe 15 might seem a lot, but in a studio or maybe in a proper center where you might need to have a very high quality, there might be multiple sort of sounds playing at once. So 15 might be nothing. So in a scenario like this, when we have to extend the possible length of the binary which or the register which would be storing the specific what do we call it, binary of a sound, if we increase the binary value like this, 1 1 1 1 1 1 1, now this can store up to how many? 255 possible values. So whenever we increase this capacity, we basically tend to say that we have increased the sampling resolution, because sampling resolution means that you have to basically deal with the number of bits which are required per sample. So like up here, the number of bits are like 4 bits per sample, right? So it was only occupying 4 bits for each sample, but now at this point it's basically occupying 8 bits per sample. So kahan pe 4 and kahan pe 8, that's a big difference. There's a very big difference. So the more you increase your sampling resolution, the better your quality would be. Why? Because the greater number of values you can store in a specific what do we call it, sample. So this is also something you all should be aware. अब इसमें ये है कि the questions are just going to be testing you on the definition. So it's really important you memorize these two definitions. And apart from that, the other part is basically just discussing the concept. So you should be well aware of what conceptually does a sample rate mean? What's the sampling resolution? So when you understand the concept conceptually, इसको याद करना मुश्किल नहीं होता. So you like at this point you might be wondering, sample rate is basically the number of samples I've taken per second, and resolution coming from the word maybe let's say size or something like that. I can say that sir ने तो मुझे ये भी बताया था कि in the topic where we were discussing what do we call it, we were discussing Unicode and all that stuff. We saw that how when we want to extend the specific register, sorry, if we want to extend a specific register, it can store multiple values, right? And while it can store multiple values, the biggest and the only drawback is that it's going to take more space. So we now know that when we want to store multiple sounds, or and definitely if I can store multiple sound at once, 255 values, maybe one could be of guitar, one could be of one vocal, one could be of the 10 other team members, one could be of the electronic guitar, one could be of something else. All that stuff, maybe if we are making, let's say, an ashid or something, and it's kind of we have 50 people standing and they all are basically trying to say an ashid at once and they're trying to create sound. तो वो सारा जो multiple sort of sample sounds at once, वो जितना आ रहा है, all of them is basically being stored in this one register. So it has a greater value, capacity. But now when we have a greater capacity, this also means that the higher you increase your like the higher the sampling resolution, sampling resolution, greater is the file size going to be, greater the file size. So if there is one problem or drawback, they might ask you as to why one should not be having a a great sampling resolution. So the answer to that is that it's going to result in a in a very great file size. And so when you have a very huge or humongous sort of file size, the problem would be कि भाई आपको ना मसला हो जाना है in the scenario where you won't be able to upload it at a low time, or you might not be able to, let's say, do specific let's say if I want to upload it through Gmail. So now Gmail has a 25 MB limit, but because it's greater than that, तो वो भी नहीं हो सकता. And so there are a few drawbacks, but at the same time the benefit would be कि yeah, definitely your quality would be literally very very good. So yeah, this officially marks the end of 1.2, where we are going to, not 1.2, basically the sound part of 1.2. So we just also discussed what the part sound constitutes of. So now before moving on, because we do have like a khasa 20-25 minutes, I want you guys to quickly let me know in the chat box, is this fully clear? And I would appreciate if you guys ask a question regarding the content too. कुछ समझ नहीं आ रही something तो पूछो quickly in the chat box. एक तो I feel like my internet is also a bit slow today. I don't know why. तो आप लोग के messages भी थोड़े late ही मुझे मिल रहे हैं. Okay, so Ramin is saying understood. That's great. Inaya, is this clear? Perfect, perfect. So no questions regarding the content. Are we very much good to go? So we can officially start off with the part of images. So we're going to be looking into images. Zyada detail mein inshallah we would be most probably guys just before ending today's class. I would let you all know. But we won't be having a class tomorrow because I would be traveling back to my university. I hope you guys are aware that I came to home over Sunday. So क्योंकि my bus was going to go from 4 p.m. to around 10, 11. So it's really difficult to manage a class during that time क्योंकि बस में या गाड़ी में मैं class थोड़ी ले सकता हूँ, right? So we won't be having a class tomorrow, but inshallah this class would be later on scheduled over some weekend. So we're gonna keep a note of all any missed class, and then we would be scheduling it over the weekend. So आप लोग को सबको बस idea होना चाहिए that you don't have to come tomorrow at 9. Inshallah we would be having a class then on Friday night. Inshallah. So yeah. So is this clear? ये अपने जहन में रख लेना. We would have a class. We won't be having a class tomorrow. See? So now we are done officially with the first two crucial parts. Now we're going to be looking into images. So when you hear the word image, what comes into your mind? You might be wondering, okay, images. Uh, यार मैं ना गया था दोस्तों के साथ and then I took a lot of images, or maybe I went to this one country and I was taking multiple pictures. Now what are these pictures? What are images? And if I say that, let's say I have a scenery up here in front of me. Let's say I went to let's say I went to the northern part of Pakistan and I see that, okay, this is the Pasukon. Okay, these are the Pasukons. And now you appear on this road in front of, let's say, Yak Grill, which is a pretty famous restaurant up there, Yak Grill. You say that, okay, let me take a picture. And so you come up and you take out your phone and you're like, okay, let me take a picture. And then you say, boom, and the whole picture comes up onto your phone. Now, have you ever wondered how this real life image goes all the way from a real life scenario into a binary digital form, where basically it is something that's stored in your computer or mobile phone? And how does your computer or mobile phone interpret that specific digital format so that it could be further on used for other purposes? अब ये हमने कभी नहीं सोचा. Today we are going to be basically studying that how does a computer represent a specific image. So we won't be studying the working of a camera. So this does not mean we would be studying working of camera. Working of camera not included. So as an hockey, you are just going and looking for how does a camera work. That's not important, not included. Really important. See, we're just going to be saying that if I have a specific image, now let's say this is my phone or maybe my laptop, how does the phone calculate and these specific colors? How does the phone ensure that I have an exact image being created of the whatever real life mountain I had? How does the computer do that? So we're going to be studying that in the topic images. Now, before moving on, it's really important that we basically define what an image is, right? So if I want to define an image at the, again, important point here to note is that in your computer, whatever image up here we have, this would be stored in binary. See? So in what do we call it? In computers, the image would be stored in binary. The image would be stored in binary. And now you tell me one thing. Can you think of a single binary number which can literally represent the whole thing? No, right? It's basically if you zoom up into a picture. Let me see if I have a picture up here. Let me see a second. Let me just create, maybe take a screenshot from somewhere. But chalo, let's say this is my home page. So usi ka ek screenshot le lete. Look up here. Say so now this is my desktop image, right? And now this has multiple colors. So now this section, this part is basically a bit darker. This is black, right? And then this is light blue. And then this is maybe a darker blue shade. And then we have a bit of white effect up here. So we can say that a white effect and stuff like that. Now this whole image is not created exactly Ramin perfect. Now this whole image is not created from a single binary code. What the software engineers and computer programmers did was that they basically divided this whole image into small boxes. and the box is so small that it cannot be further divided. So in chemistry, you would be inshallah hearing the word atom, which at your level is defined as something which cannot be further divided into something smaller. So if I have to divide this into the most smallest part, and then I basically, if I convert this in the whole screen into small boxes, and then I basically calculate the binary of a specific box, this is how your computer is basically going to be storing the value, because it's going to see that, okay, this specific box, like this up here, this one is having a light blue color. So I can say, okay, this box at top right has a binary 011010, and this could be the binary for, let's say, light blue. Then next to it, we have this box, which might be a bit more darker. So it, rather than it being 011010, it was 011011. And this could be the same, but a bit more darker shade. And now when we calculate these colors for each of this box, and then we later on combine it, we basically form an image. Now, the point here to note is that this small box, which we are talking about right now, this is basically known as a pixel, the way Ramin stated. So this is basically, when we say that an image is made up of pixel, we mean that this small box which has a specific binary value which is representing a specific color, this box is basically known as a pixel. Now, how do I define an image? So it's important, आप सबसे पहले ये देखो that an image is basically a series of pixels. See, so your image is a series of pixels that are converted into binary, that are converted into binary for further processing, for further processing, which basically means that we are basically talking about how we have all these small boxes, and then each of this small box is then further divided, is each of these boxes basically converted into a binary, and then that binary is basically used for the purpose of, let's say, photo editing, or maybe if I want to add, like if I'm writing blah 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 blah, I'm making this orange. So what's happening, I'm manipulating this image. So all these functions are then conducted by the computer based upon the specific binary value. So like if I make an orange color up here, it's not like your computer pops up with an orange color. Basically, your computer whole screen, whatever phone you're using or whatever device you have, it's basically made up of pixels. So now computer tells so basically your CPU tells the screen that, bro, your pixel number, whatever this has the unique pixel, convert its color to orange. And so on your screen, you now would be looking at this point, and it's represented as orange. And this is basically how your computer is basically storing multiple sort of colors. So pixel ko, if I have to define pixel, because in, if I'm not wrong, in your specimen exam paper of 2023, they asked the candidates to define pixel. So your pixel is basically the smallest element that could be represented on a screen, that could be represented on a screen, which means that if I divide my screen into the smallest part, something which cannot be further divided, like the atom of your screen, that box which we have up here, which cannot be further divided, and that box jiska phir humne binary value, like this can be further divided. I can even divide it like this, and then if I further divide it into the most smallest indivisible box, that is basically known as pixel. And now I'm going to be calculating the color and basically the specific binary value for a specific pixel, and then I'm basically going to be adding up all these binaries and would be storing them together, so for all of them, and then I could write them in terms of binary, and now my screen can basically represent that color. And so this is I have to show you. Yeah, sure, Inaya, sure, you can watch the recording later on for the remaining 15 minutes part, or you can stay back for like 15 minutes. We might be ending it like towards in 10 minutes. So yeah, easy if you want to stay. 10 मिनट में खत्म कर लेते हैं, because you have taken the whole class, so just like give me 10 minutes and we're finishing it. Say, so now this part is basically known as pixel. Now जब हमने pixel को देख लिया and everything, it's important that you now understand one common important word, which is known as screen resolution. So when, if you are someone who plays games, or maybe someone who goes and buy a new laptop, you might see the terms 1920 into 1368, or maybe something like 1368 into 768. This is basically representing your screen resolution. Now, a lot of you might be gamers, and so if you are gamers and you go to your game setting part where you look into the video section, you might see that your screen resolution would be an option present there. So you can choose multiple screen resolutions, and the screen resolution basically represents the number of pixels your screen has. So like if I say that there is a specific monitor, a monitor which has basically 1920 length, or maybe 1368, something like this. So if I basically see the length and the width, I can basically get an assumption of the number of pixels the screen has. How I can say that one basically part up here represents one pixel. So if I have to find the maximum number of pixels, we have like 1920 pixels like this, and then I have 1368 pixels like this. So if I have to find the total number of pixels, it's basically going to be 1920 multiplied by 1368 will basically give me the total number of pixels. And this basically allows me to understand, okay, how many different colors can the screen have? Because every pixel is going to have one color, right? So I can have this many total number of pixels, which could have so many different color combinations. Now, screen resolution, if you ever later on see it on your screen or in whatever game you're playing, you should be understanding that screen resolution refers to basically the total number of pixels that are present in the screen. So screen resolution refers to the total number of pixels, to the total number of pixels on a screen. So if you are ever asked to tell us how can you figure out the total number of pixels, let's say Rayan has on his screen, so you should be knowing that you can calculate the total number of pixels through the screen resolution, because screen resolution tells you the dimensions of your screen. So it tells you how, what's the width, what's the length, maybe what's the diagonal length, and based upon that, it allows you to interpret that, okay, if we have this much length worth of a screen with this much width, it can have this many total number of pixels. We can also write it as width into breadth. Is basically going to give me the same total number of pixels. So now this is really important because at this point you might be asked in exam that, bro, a specific screen is present which has 50x30 resolution. 50x30 resolution, and you're told to, bro, calculate the total number of pixels, because these pixels are really important if I have to calculate the file size, because later on inshallah in the next class we're going to study how we will be calculating file size. So what you can do is you can just literally multiply 15 to 30, and that's going to be 1500. So I know that if a screen resolution reso of 50 into 30 for a screen is present, this has basically 1500 pixels on the screen, which allows it to have so many different colors. But just like that, अगर मैं इसको वो करूं कि if I want to say कि screen resolution के अंदर what is basically all these total pixels, so it's basically the number of pixels in the xy direction. So when I say length and width, I'm basically talking about how I'm basically moving in the x direction. So it's like 1920 in the x direction like this, and then 1368 in the y direction. So when you multiply these two, you get the total screen resolution, and this is also something जो कि आपको पता होना चाहिए. Apart from that, the more number of pixels you have, the better your quality is going to be. Say, so let me write this up here. The greater the number of pixels, the greater the number of pixels, the better the quality. The quality. Now, what do I mean by this? Basically, by this, I want to say that, let's say I have a screen. Now, if on the screen I have, let's say, 4 pixels, if I divide the screen into 4, now you all are aware that each of this box can have a different color. So maybe it can have a yellow color up here, maybe it can have a green color up here, maybe this part can have something like a pink color, and I can change this to, let's say, maybe blue. Yeah, actually, let's do blue. See, so we get, oh yeah, blue हो just select. So bring this blue up here. इसको कैसे हटाना है यार? Never mind, I want to change the color for this, but I cannot. Okay, yeah, through this. Okay. So now this section might be blue and all that stuff. Now I'm basically having how many colors? I'm having 4 colors at this point, right? But now you tell me if I have a screen which has 16 pixels, now it might be having the same size, okay, ye thodi badi ho gayi, let's make it of the same length. So let's say we have a screen like this, which is almost the same size. But now rather than having 4, we have now 16, which means 1, 2, 4, 6, 8, 10, and then let's say if I divide this is going to be further, and let's say let's convert it even more. So 1, 2, 3, 4, 5, 1, 2, 3, 4. So 5 into 4 is 20. So this is now 20 pixel. Now when I have a 20 pixel screen, I can have even more colors. I can have a blue up here, then I can have a green up here, I can have a yellow up here, I can have a pink up here, and I can repeat it. Maybe I can add red up here and all that other colors. And so in a scenario like this, I can basically represent way more colors, right? So the higher the basically number of pixels I have, the greater the quality. Why? Because I can represent more colors. So more pixels allows the computer programmer, allows the computer, kar lete hain, computer to represent more colors, to represent more colors. So for that reason, you might be saying that these newer monitors, they are increasing their screen resolution. Or if I say that, let's say you have a 4K TV, so a 4K TV usually has a very very high screen resolution. And why does a 4K TV have a very high screen resolution? Because the greater your screen resolution is going to be, the greater the number of pixels it's going to have. And when it has a lot of pixel, it can basically represent multiple colors at once. So like at this point, you can observe that we have one image being displayed, but it has 20 different colors. And so it would be way more real, right? In comparison to this, where we only had 4 colors, so it might not be looking that real. And so this also allows us to evaluate how, when you want to increase the quality of a specific image, you basically increase the number of pixels. So now I have this one image. I took it from Google back then. Google Pixels, एक सेकंड मैंने कहीं पे किया था, let me reopen it. Google, एक सेकंड, रिसर्च गेट की कोई इमेज थी, इस तरह करेंगे pixelated image. Let me see if I get it. I hope so. Because it was pretty good back then. Just give me a minute and then we can end the class. So till now, do you guys have any questions or are we good to go? I'm not sure how good of the recording would be once it's processed. I hope it's not lagging. Otherwise, we are really cooked. Chalo, that's great. If you guys understood the concept right, that's what's the most important part. Okay, perhaps this is not working. Let me get one image for you guys from the book. So like up here, this was the one image from the book. And you might have observed sometimes that when you focus upon some image or you maybe zoom into something, it becomes blurred. Now, why does it become blurred? It basically gets blurred because the moment you increase the size, you don't have enough pixels. So this image has, let's say, 20 pixels, but your monitor or your computer right now has maybe 100 pixel capacity. Now when you try to bring a 20 pixel image into 100 pixel form, it's going to get blurred. So this is going to get blurred like this. But now let's say I have 100 pixel monitor up here, so like 100 pixel up here, and I bring this one image which is also of 100 pixel. Say, so if I also bring this 100 pixel image onto my screen, it's going to be in a very sharp, high quality. So this is also one other aspect of the paper. You all should be aware that when we are talking about basically the number of pixels, the greater the pixels are, pixels greater, the quality would also be higher. And the lower your basically number of pixels are, the fuzzy your image would be. So you see this image is pretty fuzzy, or I can also say it's blurred. And that's one reason, agar aapse kabhi koi पूछे, when you zoom into a specific image, why does that become blur? Because the specific number of pixels of that image is not enough to the number of pixels our screen have. And so because they do not match, this 20 automatically tries its best to become 100, but that's something not possible because it then messes up its actual existence. यही वजह होती है कि जब आपकी कोई blur image होती है on your screen, or maybe if you're using a PowerPoint presentation and you might enlarge an image, it might get blurred. But then when you again reduce the size of it and you make it something like of this length, now it's again clear. Why? Because now at this point, if it was of 20 pixels, it's only occupying 20 pixels of your screen, so it's of high quality. But when you try to extend it, it's going to take more space, and then this would basically lead to a lower quality. So extension से ये मसला हो जाता है, unless your image has a higher number of pixels, it won't work well. And this marks the end of our today's class. Inshallah, in tomorrow's class, we would be dealing with some few concepts related to not tomorrow's baad wali jab bhi hogi inshallah. So you're going to be discussing the benefits of sound and also some bitmap images concept, and then also I would try to include the data storage part, which is 1.3, so that we can quickly end the topic inshallah in next week and then jump on to some past paper questions. See, so let me write it up here too ke humne dekhne advantages slash disadvantages of sampling. We even though discussed this a bit, I want to do it even in a bit more detail, and apart from that we would be looking into bitmap images. So inshallah this would be the agenda for our upcoming class. Inshallah we won't be having a class tomorrow. Inshallah we're going to see if we can have a class on Friday. Inshallah we would. So that's all for today. Before ending the class, can you guys kindly confirm if you got the concept, or if there is anything which is not clear? You guys can literally just send a message, drop your questions, and we can have a discussion on it. So, are we totally good? Did you guys get the concept? Perfect. Ramin, Inaya, is this clear? Or do you have any questions? Chalo, that's so much great to know. Okay, so guys, with that, it's 9:59. I would be ending the class. Again, apologies if the screen was a bit of low quality today. I don't know. Maybe the internet here was a bit faulty for some reason. It's not working since morning. But inshallah, it would be fine once I get back to university. So, yeah. Chalo, फिर everybody take care. See you guys inshallah in the next class. Allah Hafiz.